Hello students, and welcome to another video. In this lesson, we're going to be learning about the mean value theorem and Rolle's theorem, which is really just an offshoot of the mean value theorem. We're going to have 3 videos in this series, so let's get started. Alright, so we're going to start here where we're going to consider the values of a differentiable function in this table. What we're going to do is let's take these values and let's plot them onto this table right here. All right, so hopefully your graph came out to be very similar to what we have here. And what we want to think about as we're going to look at this graph is that in calculus, the derivative has a lot of different interpretations. But kind of the most common is the derivative means the rate of change. When you think of rate of change, you want to think about derivative. Something like miles per hour, that just means derivative. So there's 2 ways that we can think about functions that have rate of change. There's the average rate of change, and then there's the instantaneous rate of change. So the average rate of change is going to be on an interval from A to B. The average rate of change is f of A minus f of B over A minus B. And you might also know this as y2 minus y1 over x2 minus x1. That's just how we find the slope. Really, when you connect 2 points, you're finding the slope. And so if we're connecting 2 points on a curve, we're looking for the slope of the secant line. So now what we want to also think about is that instantaneous rate of change. What do we do when we're finding the instantaneous rate of change? Well, that's really at a value, something like x equals a or some other value, the instantaneous rate of change is f prime of a. So now we're using that derivative to find the instantaneous rate of change. So we know how to find the average rate of change, we know how to find the instantaneous rate of change. So what's our first question here? Well, we want to find the average rate of change of f of x on the interval from 2 to 12. So really, okay, we want to find f of 2 minus f of 12 over 2 minus 12. And you solve this out and you should get 3/10. And all I did was either grab the values from the table or grab the values from the graph. So let's really go up to our graph here real quick. And let's look at 2 and 12 and let's connect those. So f of 2 right here, f of 12 is right here, and let's connect those. And so we're gonna have a secant line just like that. So now what we wanna do here is we want to find the instantaneous rate of change. What's the instantaneous rate of change? Which one's greater, the instantaneous rate of change at x equals 4 or the instantaneous rate of change at x equals 6? All right, so let's kind of draw the tangent lines. So here's 4, and so the tangent line would look something like that at 4, pretty close. So we would draw another one, let's make it green here at 6. It would look something like that, okay? So as we're looking at them, you really just want to compare, all right, which one is steeper, the red or the green line, because that's going to be our greater slope. You can see the red line is greater, which is the tangent line at f of 4. So let's go ahead and let's say that f prime of 4 is greater than f prime of 6. And the reasoning why this is true is because the tangent line drawn at x equals 4 is steeper than the tangent line drawn at x equals 6. All right, so now let's go ahead and let's move on to what is Rolle's theorem. So what Rolle's theorem states is that if f of x is continuous on the interval from a to b, and it's also differentiable on the interval from a to b, and f of a equals f of b, then there is a guaranteed value c to exist on a to b such that f prime of c equals 0. So really what that's saying is if we have 2 even points, then at some point in between there needs to be a maximum or a minimum, or it could just be flat, but at least one of those things is going to be happening. All right, so now let's actually consider some of the intervals on the previous page, and let's determine whether or not Rolle's theorem will exist there. So If we're looking on the interval from 2 to 14, does Rolle's theorem work in that case? So really you want to come back up here and you want to look at this graph, or you could look at the table, and let's take a look at 2 right here and then 14 over here. And what you want to notice is that both of those points have the exact same y value. So what's happening is that there has to be a point somewhere in between there where the derivative is going to be equal to 0. You can see that happening right there at x equal to 8, where the derivative is going to be flat, where the derivative is going to be 0. So let's go ahead and write that down. So that's kind of how you would type up the exact verbiage that we had done with Rolle's theorem. You have to make sure it satisfies all the conditions: continuous, differentiable, and the values are going to be equal. They're going to be equivalent. They're the same y values. And so then we can guarantee a value and state what that value or what those values are. Now let's look at the interval from 2 to 8 in this case. So again, we're looking at 2 and we're looking at 8. So if we're going to look at 8 here, we can see that there are 2 different y values. So Rolle's theorem specifically states that the first value and the second value need to be the exact same. So we are continuous, we are differentiable, but the y values are at 2 different levels. So we can't actually apply Rolle's theorem in this case. So let's go ahead and write that one down. All right, so now that we know when Rolle's theorem can be applied and the specific conditions that it needs to be under, let's go ahead and apply it to these 2 problems. If it can be applied, let's actually find the value where it will work, and then if it can't be applied, let's state why. So in our first problem here, we have 9x squared minus x to the 4th. So what I'm noticing here is that g is a polynomial function between -3 and 0. And so since that's happening, it is a polynomial function, we know that it is continuous and it is differentiable everywhere on that interval. All right, so since we had those 2 conditions met, let's see if the last condition meets out. So we first need to find, okay, what is g of -3? And we need to find g of 0. And we need to make sure that both of those work, that both of those are equivalent in order for Rolle's theorem to be applied here. So g of -3, so if I substitute that in, I get -3 squared, which is 9, so 9 times 9 is 81, minus -3 to the 4th, which is 81, so 81 minus 81 is going to get me 0. Then if I substitute 0 into both of those x values, I also get 0. So therefore, we're going to say that Rolle's theorem can be applied because it's continuous, it's differentiable, and g of -3 equals g of 0, which is 0. Okay, so what's the next step into finding that guaranteed value? Well, we need to find g prime. So let's find g prime of c. And so just replace all those x values with c. And we take that derivative, and let's see, we're going to get 18x minus 4x cubed. And what we want to do is, because we know that it's going to be equal to 0, Rolle's theorem states specifically that it'll be equal to 0 at some point because those 2 other values are even, we're going to say set this equal to 0. Well, I could factor out a 2x from here, so 2x times 9 minus 2x squared equals 0. Okay, and let's solve for x. So I get 2x equals 0, x equals 0, and then 9 minus 2x squared equals 0. So I'll get 2x squared equals 9. X squared equals 9 halves. Take the square root of both sides. And so we're going to get x equals the positive or negative square root of 9 is 3 over the square root of 2. So we have 3 x values. We get 0, and we have positive and negative 3 over square root of 2. But we want to think, right, we could have multiple values where Rolle's theorem can come out to be guaranteed values. But when we're saying what c is, we want to say here, and actually all those x's, as I was doing all this work, all those x's should have been c because we are replacing, we're solving for that c value. But honestly, it doesn't really matter whether or not you leave it as x or you put it as c. But we want to think specifically, okay, what is the interval being applied here? Well, we're looking between -3 and 0. So positive 3 over the square root of 2 is going to be outside of that interval. 0 is an endpoint, and since we need it to be differentiable on an open interval from -3 to 0, we also can't include that. So the only value that falls between -3 and 0 is going to be the -3 over square root of 2. So you also still need to think critically about what type of values you're getting here. And finally, let's take a look at this last problem. We had g of x assigned 2x on x plus 2, and we're looking on the interval from -4 to -1. And I do have a rational function here. And so I want to note that g of x is undefined at x equals -2. And since x is -2, since it's undefined at x equals -2, that is within that interval from -4 to -1. So Rolle's theorem can't be applied because g of x is not continuous. It has to be continuous over the entire interval for it to be applied. Alright, so that's going to conclude our analysis of Rolle's theorem. In our next video, you're going to be introduced to the mean value theorem, which is a lot more powerful than Rolle's theorem and a lot more relevant to AP calculus. Rolle's theorem is a nice way to get your feet wet, but the mean value theorem is going to really explode everything that you just did here. You're going to see how much more powerful the mean value theorem is. So if you do need any help understanding what Rolle's theorem is, please reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.